Welcome to my presentation. This presentation is part of the playlist Integration by Substitution. In this presentation, we will be solving example problems using integration by substitution. Let us look at an example. We want to evaluate this integral. Integral 3x squared, open parenthesis, x cubed plus 1, the whole thing raised to the power of 10 dx. We're going to use integration by substitution to solve this example problem. Let us substitute u as equal to x cubed plus 1, the one which we have here, x cubed plus 1. So we want to differentiate u with respect to x. Since u is a function of x, we want to differentiate it with respect to x. Du by dx is equal to 3x squared. d by dx of x cubed is 3x squared, and then d by dx of 1, which is a constant, is 0. So we did not write that. 3x squared plus 0 is still 3x squared. So we can write this one as du is equal to 3x squared dx, like that. Okay, then dx I can write as 1 over 3x squared du. If I want to express in terms of dx, I can write it as 1 over 3x squared du. Now we can substitute u as equal to x cubed plus 1, like that, and then dx as 1 over 3x squared du into the given example problem and solve it using integration by substitution method. So our given example problem is 3x squared times x cubed plus 1, the whole thing raised to the power of 10 dx. So wherever we see x cubed plus 1, we're going to substitute by u. So 3x squared, integral 3x squared, then x cubed plus 1, we're going to replace it by u, and then this thing is raised to the power of 10, so u to the power of 10, and then instead of dx, we can write 1 over 3x squared du, like that. Okay. Now, as you can see here, we have 3x squared in the numerator, 3x squared in the denominator, so those terms cancel out, leaving us with u to the power of 10 du. Integral u to the power of 10 du. Now we're going to integrate this function using the rules of integration. So integral u to the power of 10 du we can write as u to the power of 10 plus 1 divided by 10 plus 1 plus c, where c is a constant of integration. So in the next step, we can simplify it some more. U to the power of 10 plus 1 is u to the power of 11, and in the denominator we have 10 plus 1, which is 11, plus c. So wherever we see u, we're going to replace it by x cubed plus 1. X cubed plus 1. We cannot leave our solution in terms of u. We need to express our solution in terms of x. So therefore, wherever we see u, we're going to substitute x cubed plus 1 into that equation. So 1 over 11, the 11 is in the denominator. Instead of u, I can write x cubed plus 1, and then this whole thing is raised to the power of 11 plus c, where c is a constant of integration. So this is the way we're going to solve example problems using integration by substitution. Let's look at another example. Let's say we want to evaluate this integral 2x x squared plus 1, the whole thing raised to the power of 23 dx. So we're going to use integration by substitution to solve this example problem. Let us substitute u as equal to x squared plus 1, which is in the parenthesis here. Since u is a function of x, we can differentiate it with respect to x. We can differentiate u with respect to x. So du by dx is going to be equal to d by dx of x squared is 2x, d by dx of 1 is 0. We did not write that. So du by dx is equal to 2x. So I can write du as equal to 2x dx, like that. So if I want to express it in terms of dx, I can write it as 1 over 2x du. Now we can substitute u as equal to x squared plus 1, like that. And then instead of dx, I can write 1 over 2x du, like that, into the given example problem and solve it using integration by substitution. So our given example problem is 2x times x squared plus 1, the whole thing raised to the power of 23 dx. So now, wherever we see x squared plus 1, we're going to substitute that by u. So integral 2x u to the power of 23, instead of dx, we're going to write 1 over 2x du as shown here. Okay. Now, since we have 2x in the numerator, 2x in the denominator, those terms cancel out. And when we simplify it, we can write it as integral u to the power of 23 du. Now we're going to use the integration process to simplify this. Integral u to the power of 23 du, we can write as u to the power of 23 plus 1 divided by 23 plus 1 plus c, where c is a constant of integration. And then u to the power of 23 plus 1 translates to u to the power of 24. And in the denominator, we have 23 plus 1, which translates to 24. So we need to substitute u as equal to x squared plus 1. And that's what we mentioned here, right? So therefore, wherever we see u, we cannot leave our solution in terms of u. We need to express our solution in terms of x. So therefore, wherever we see u, we're going to write x squared plus 1. So 1 over 24, x squared plus 1, the whole thing raised to the power of 24, plus c, where c is a constant of integration. So this is the way we're going to solve example problems which involve integration by substitution. In my next video presentation, we will solve some more example problems related to integration by substitution.